This video is about counting atoms. It's a little bit more advanced. We're actually going one step further from molecules, if we know how many molecules or formula units of something. We're going on to tell how many of a particular atom are in that molecule. So let's look at some example problems. In this problem, we're being asked how many hydrogen atoms are in 5.5 times 10 to the 23rd water molecules. Now we know the formula for water, I hope, H2O. So in each molecule of water, there are 2 hydrogen atoms. So we should have twice as many hydrogen atoms as water molecules. Let's set that up as a factor label. 5.50 times 10 to the 23rd molecules of water. And we know that in one water molecule there are 2 hydrogen atoms. And what we can do is set this equality up like we have in the past as a conversion factor. So we're going to want molecules of water on the bottom, and we want atoms of hydrogen on the top. And we know that in one molecule of water there are 2 hydrogen atoms. And so go ahead and multiply that on your calculator, and you should get 1.10 times 10 to the 24th atoms of hydrogen. Sometimes we're only interested in one particular atom in a compound, such as lead or calcium. Now we're able to go from the water, the molecules of water, to a specific type of the atom in the water. And that's what we're going to be doing for the rest of our practice problems. So let's look at another one. In this problem, go ahead and read it. We're being asked to find the mass of carbon dioxide that is needed to obtain 4.50 times 10 to the 22nd atoms of oxygen. So it's asking us to find a mass of carbon dioxide, but it's giving us the atoms of oxygen. It's giving us information about one thing, the oxygen, and it's asking us for information about carbon dioxide. So in order to do that, we need to make that transition in our calculation from oxygen to carbon dioxide. We know that for every 1 molecule of carbon dioxide, for one molecule of carbon dioxide, there are 2 atoms of oxygen. So we're going to need to use that factor in our calculation somewhere to go from atoms of oxygen to molecules of carbon dioxide. Once we figure out our molecules of carbon dioxide, we know how to go from molecules to moles, and then from moles to mass, just like we have in earlier calculations. So let's set this up. We're going to start with our 4.50 times 10 to the 22nd atoms of oxygen. And we're going to set up our first conversion factor. We want to go from atoms of oxygen, so we need that on the bottom to cancel, to molecules of CO2. And we know that in 1 molecule of CO2, there are 2 atoms of oxygen. Now that we have our molecules of CO2, we know to go from molecules to moles. We're going to put molecules of CO2 on the bottom. And we want to put moles of CO2 on the top. And the numbers that we use there, we are talking about the number of particles in a mole. Our conversion factor from moles to particles and vice versa is Avogadro's number, 6.022. times 10 to the 23rd. And that's the number of molecules in 1 mole of CO2. And now that we've done that, we've got moles, we know to convert from moles to mass using molar mass. So we're going to set up that conversion factor. And we have moles of CO2 on the bottom to cancel. And we have grams of CO2 on top, because that's the unit that we want in our answer. Grams is a unit of mass. And you should add up the total molar mass of CO2, 1 carbon and 2 oxygens. That tells you that the molar mass of carbon dioxide is 44.01, and that is the number of grams in 1 mole of CO2. And when you calculate this out, you should pause and do this in your calculator, you should get 1.64 grams of CO2. We're just adding in one extra step there. We're converting from atoms to molecules. We can also do this same thing with formula units and ask for ions. Or we could do a problem that's similar to this but in reverse. So we could start with a mass of carbon dioxide and we could ask for atoms. Let's look at a different example. In this problem, we're being asked how many oxygen atoms are found in 10.0 grams of glucose, which has a formula of C6H12O6. We know that 1 molecule of glucose contains 6 oxygen atoms. And we know that we're going to have to use this conversion somewhere in our problem to help us get to the oxygen atoms. We're being given information about the glucose. We're being given the mass. So that's where we're going to start. So we have 10.0 grams of glucose, C6H12O6. And we're going to do what we have in the past. We're going to convert from grams. We need to put that on the bottom so that it will cancel. C6H12O6 on the bottom. And then we want to go to moles. We need to go to moles before we can convert to molecules. So moles of C6H12O6. And in order to find our molar mass, we need to add up all of the atoms in our compound. So we have 6 carbons, 12 hydrogens, and 6 oxygens. When you add that up, which I hope you do without waiting for me to do it for you, it's 180.156 grams per mole in 1 mole. That's the number of grams in 1 mole. And then we know that we're trying to get to atoms. In order to get to atoms, we're going to need to get to molecules. So we want to go from moles to molecules. So we need to have moles on the bottom here to cancel out. And we're going to have molecules of C6H12O6 on top. And we know that in order to convert from particles to moles or moles to particles, we need to use Avogadro's number. That's the number of particles or molecules in 1 mole, 6.022 times 10 to the 23rd molecules in 1 mole of anything. So now that we have done that, we have got our molecules, and we can go from molecules of glucose to atoms of oxygen. We're going to go ahead and set up that new conversion factor. So we want on the bottom, we want molecules of C6H12O6, and we want atoms of oxygen on the top. And in our equation, we have 1 molecule containing 6 atoms of oxygen. Now go ahead and put that into your calculator. You should end up with 2.01, that's a decimal, times 10 to the 23rd atoms of oxygen.